Hello, I'm Dr. Harper. This video is a lecture in operations management on ABC inventory classification. So let's bring up the notes. Now in inventory classification, you have some definitions. First of all, you have the SKU items here, and a SKU stands for stock keeping unit. And a stock keeping unit is like in a barcode when you sell something. It's a unique identifier to the item within the inventory. Then you'll have annual usage, and this is in dollars. For example, suppose you have an item, a SKU item number 5, and this SKU item was a bottle that you're selling in your retail store, and it's a very popular water bottle. And over a year, this is annual, so over 1 year, the bottle was $1, and so you the turnover, the dollar turnover in your inventory, $1 came in, $1 went out, $73,728 worth of inventory came in and went out. That's the annual usage. So it's the dollar turnover in your inventory. There are different definitions of usage. That's the definition we will use. So we have all of these SKU items. Suppose we only had 10 SKU items, and these are the SKU numbers. But then we have the annual usage of each one of those SKU items. So what we do is we rank order it. That's why these numbers are not ordered, but the annual usage is rank ordered from the highest to the lowest value. We take the total sum, and then we divide through by the total to get a percent usage. And there's the percent usage. You can see that 73,728 is 64.7% of 113,920. These are all in dollars. 18,432 is 16.2% of the total. And down here, SKU number 2, which is $747 turnover, was only 0.7% of the total. Okay, and then so you say, okay, well, I'm going to look at the cumulative percentage of these. And if I do that, my cumulative percentage then, in this column, I take 64.7. 64.7 plus 16.2 is 80.9. So these first two SKU items together make up over 80.9% of the total annual usage of my inventory of these 10 items. So those two items command over 80% of my usage. But then I keep going on. Well, then I have 88, 91, 94. Well, let's start categorizing these. So let's say, well, 80%, let's call those Class A items. The percent usage of those Class A items is 80.9%. We just copy that over. Now the percent of the items, well, there's 2 items out of 10. 2 out of 10 is 20%. So 20% of the items make up over 80% of the percent usage when you look at the dollar usage. So that's an indication of something called the Pareto law, or the Pareto rule, or the 80-20 rule. And it's a very common occurrence in business, in inventory, and any time when you have any type of measurement, monetary measurement of free enterprise. So you have Class A items 70 to 80%. And notice I say 75 to 80%. Well, this is over 80%. Okay, so these are just fuzzy intervals, somewhere around the 80%. 10 to 20% of the items. Then the Class B items is 10 to 15%. Well, 10% more than 80 is 90.9, so the next two is 10%. But then 15% would be 95.9, that's 94.4. So one person might say, well, I think the next 2 items will be my B items. Well, I chose the next 3 items to be my B items. So again, these boundaries between A and B are arbitrary. We'll talk about that more in a minute. So I selected B to introduce the ABC classification. So now I classify SKUs 1, 6, and 4 as my B items, because I take 94.4 minus 80.9, and those make up 13.5% of my usage. There are 3 items out of 10, so they're 30% of my items. So 30% made up 13.5% of my usage. I classify those as my Class B items. Now the rest of the items, which I take the 100% minus 94.4, is 5.6. So the remaining 5.6% of my dollar usage, of my dollar asset, of my inventory, is 50% of my items. And so this is a very common breakdown. It breaks down this way quite often. Okay, so that the reason you classify it this way is that when you start managing your inventory, your Class A items are going to have a lot more attention, a lot more effort, more analysis. You're going to focus a lot more on those items because you're managing 80% of your inventory. But in the class, for example, you might have contracts with very specific suppliers, maybe multiple suppliers, and long-term contracts or significant contracts with your Class A items. So you have very high-level contracts with lawyers looking at them, etc. Now your Class B items are important, but they're not as important as Class A at all. You do have some control. And examples of Class B control are things like approved catalogs with limited amount of purchasing power, or you have certain type of vendors that you go to with limits on how much can be bought from them at a certain time over time. Or you might have competition that they may be Class B items because they may be competition with sales, okay, with price points or even the supply risk of those items. Okay, but then the Class C items or the C items down here, that's usually driven by price point. Since they're cheap, let's buy a lot of them. Usually the lot size is large. The frequency is low. You buy them once every 6 months, buy as many as you can, and you try to have discounts. Usually it's driven by price point with discounted price points here. Usually these are driven up here, they order a much higher order frequency, and so you'll order them like every 2 weeks or every 3 weeks to stay on top of them, as an example. Class C items are just very low frequency, once every 6 months. Why? Because you order in bulk. You order in bulk because they're cheap. And so therefore you can save money and actually save ordering cost from placing too many orders. And the B items are in the middle. Okay, so that's just a really good way to organize how you're going to manage your inventory. Well, let's see a little bit more on the practical side. Well, down here, when you start classifying this, it's easy to see these percentages when you have only 10 SKU items. But what if you had 1,000 or 10,000 or 250,000 items? You're not going to look at a table. Instead, you can do it very easily visually. So what I'm doing here, I'm plotting this. I'm reordering the SKUs from 1 through 10. Okay, this is 1 through 10, 1 through 10 SKUs. But here, I'm plotting my SKUs, my ranked order SKUs here, on the annual usage in dollars. So I take this annual usage right here, these right here, and I plot them 1 through 10. And that's this plot right here. And you can see how it goes down. This one is a cumulative percentage usage. So the cumulative percentage right here, I plot these versus 1 through 10. And you can see them right here. So at this point, you could say, okay, well, there's 10 dots here, but what if you had 250,000? Well, they're going to be, you can go from, and you can rank, then you can also divide by the total and have 0 through 100% or 0 through 1. The point is you'll have a graph, and everything is right here. This would be like a continuous curve. But they say, okay, well, where's my Class A items? Well, they're around 80%. So let's come up here and take this insert, my shape, and take this box here and say 80%. Let's come across here, somewhere around 80%, and come down here. There's my 80% right there. I'll come across here. I could pick that one, or I could pick this one. I'll go up here. I'll pick this one here. Remember, I went a little bit above 80%. And let's shape fill. Let's make this, let's keep it blue. I like the blue. Nothing wrong with the blue. Keep it blue. But the shape fill, make it no fill. And then the shape outline, keep it blue. So there's, you say, okay, well, these right here, these SKUs, here's the 80%, these are my A items. Okay, then I take this, I say, okay, well, let's copy this. And what about my B items? Well, let's bring this up here. Next 10, 15%. Let's come all the way to here. Let's extend this, and there's my B items, these next three. Okay, now what about my C items? Well, let's come here and do my C items all the way to 100%, and that's going to be the rest of them. And there they are. So notice how fast you can do this. There's your A, there's your B, there's your C. But then once you do that, you sit down with a planning committee and say, these are the A items. Let's look at the boundary between A and B. Are these items right here, are they really A or are they really B? Because remember, the A items, you're going to be doing a lot of effort here. So let's suppose you might have a couple, 300 or 400. We don't have enough resources to do 300, but we can do 150. Fine. So let's start going here and start working our way and say, how many of these do we move to the B class? And how many of the Bs are really important? We move them to the A class for maybe other than monetary reasons. And same for the B and C. So these boundaries here are very, I would say, fuzzy boundaries. They're really practical boundaries. It doesn't take long to say, this is our A set, this is our B class, here's our C items. And then you say, here's your people to manage these A items, here's your people to manage the B, and here's the management of the C. So it's very, very quickly, you can classify this and spend most of your time on focusing on managing your inventory rather than trying to figure out which inventory items to manage. Okay, and so it's a very quick way to do it. It's a very effective way to do it. It's a way to manage your effort. It's very popular. But let's go a little bit deeper. Let's go a little bit deeper and let's look at a cost analysis of an ABC classification. So let's evaluate the arbitrary inventory policy. Now I'm saying this inventory policy here is the order frequency. So I'm saying, okay, I'm taking this classification. So I do have this classification of 2, 3, and 5 for the same inventory. So let's come down here, say, okay, well, here's my 3 classes, A, B, and C, and I have my number of SKUs is 2, 3, and 5, and let's add up all of the usage of B and all the usage of C. In other words, 92,160, that's going to be the sum of those two numbers. Sum these 3 numbers, and that's going to be my total usage for my B. Same for my C. Then I sum all the C's. So there's my annual usage for the classes, and there's my number of SKUs for the classes. Now this represents my inventory policy. And what I mean by inventory policy is every one of those items, I'm going to order it 10 times a year. Every one of these items, I'm ordering it 8 times a year. Every one of these items, I'm ordering it 4 times a year. So that's going to be my order frequency. Well, I'm calling that an inventory policy because if that's my inventory policy, that says exactly how you're going to order them. Okay, but then how much do you order? Well, we'll look at that here in just a second. So you can analyze this. You can analyze this and say, okay, well, if each of these SKUs I order 10 times, well, then 2 times 10, my total orders over the year for my A items is 20. Well, it's going to be 24 for my B items. 4 times 5 is 20 for my C. So I have a total, my total here is 64 total orders for my purchasing department. That's all the orders they're going to be placing over the year. Okay, let's assume our unit ordering cost is $40 per order. So I bring it down here. My unit cost is 40. 40 times 64 then turns out to be $2,560 over a year. Now, what about my average inventory? Well, I have my dollars over here, and each one of my SKUs will be ordered 10 times. Okay, so if I take my annual usage in dollars and divide by 10, then that's going to essentially be how much each order is going to be. But if I divide that by 2, I get my average inventory. So this 92,160 divided by 10 divided by 2 equals my average inventory. And this comes right out of the fundamental relationships, fundamental equations and fundamental relationships of inventory theory, where the dollars is your demand, here's your frequency, and then D over F divided by 2 is your average inventory. Okay, so you do that for each one of these. 15,360 divided by 8 divided by 2 is 960. And so you add these up. And so on the average, you're going to be carrying $6,368 worth of inventory on the average throughout the year. Well, the unit carrying cost is 25 cents per dollar per year. We have $6,368 times the unit carrying cost per dollar. We multiply that, and we have our total carrying cost of $1,592. So let's add these two together. My total inventory cost is $41.52. So the question is that a minimum? And the answer is no. So this is not an optimal inventory policy because it doesn't really minimize my total inventory cost. How do I know that? Well, from inventory theory, from EOQ theory, at EOQ, the total ordering cost equals the total carrying cost. These are not equal. Actually, the ordering cost is higher than the carrying cost. If this was optimal, then these would be equal. Since they're not equal, then that inventory policy is not optimal. So I'm ordering too many times. These orders are 64 is too high. So my 60 to 68 is too low. So this needs to be higher, this needs to be lower. I adjust that over here in my order frequency. So how do we determine an order frequency to minimize the total inventory cost? I'm not going to derive that here. I derive it in another location, another paper. The order frequency per class to minimize cost is given by this equation. It's the square root of the usage for each class, square root of the usage, M, divided by 2 times N, times something called EPP. Now, EPP is the ratio of the ordering cost to the carrying cost. We notice the ordering cost is 40, the carrying cost is 25 cents. Well, that ratio of 40 to 25 is called EPP. That turns out to be something called the economic part period. And actually, it's the economic monetary period. We're talking about dollars, not parts. But down here below, I will derive that and show what that means in a minute. Right now, let's just put it in this equation. We multiply it. We bring down our usage. These three usage right here, 92, 15, 360. Bring down the 2. The 2, 3, and 5 is right here, 2, 3, and 5. The 40 over 25. Do the arithmetic. Then I get 12, 4, and 2. So I come down here and I put this into my order frequency, and I go through the same analysis. Well, my N's times my F gets my frequency. My usage divided by my F divided by 2 is my average inventory. And there's my total. And notice, I said this was too high. The 46 went down to, the 64 went down to 46. I never noticed this before, but essentially we just reversed the numbers and made them smaller. No, that's not what it did. But that is what happened. But anyway, and also the 6,368, and notice what happened was, since this came down so much, this went to 7,360. Okay? But more importantly, if I multiply this by the unit costs, notice my total ordering is 1840, my total carrying is 1840, therefore this is a minimum. interesting. Okay, but let's analyze this a little further. Let's look at the EPP. The EPP carries a lot of information. The EPP, economic part period, the ordering over the carrying cost, is the same as the average inventory over the order frequency. Let me illustrate this. Take the EOQ equation, which is the square root of 2 times D times C sub over C sub C. Now this D is the demand. And the D could be a demand of items, or it could be the demand of dollars. And so instead of D, I could put M in there for usage. The demand could be in units of items or in units of dollars. Let's look at items. Okay, and rearrange. In other words, I'm going to square both sides. I take the Q here. I square both sides, so the square root goes away, but Q times Q on the left-hand side. I take the 2D and bring it to the left-hand side. I divide Q over 2, and then I bring Q in the denominator, D over Q. And notice Q over 2 is your average inventory. D over Q is your order frequency, and that's equivalent to the ratio of the C sub O ordering cost to the unit carrying cost. So the idea here is that this expression, which is labeled to be this, came from the EOQ equation. So therefore, this Q, this lot size Q, came about from an optimal minimum cost calculation. So therefore, the average inventory over order frequency is that ratio. Well, let's see if that's true. Let's come up here and say, here's my average inventory, and there's my order frequencies, right? So if I take my average inventory, 3840, divided by my order frequency of 24, that ratio turns out to be 160. 1920 divided by 12 is 160. 1600 divided by 10 is 160. As a matter of fact, I'll ask you, if I took 7360 divided by 46, would I get 160? I hope you said yes, because you would. Okay, so EPP is an optimal EPP to minimize your cost. Okay, and so therefore, this really represents different types of applications. Okay, I don't go into them in this video, but this suggests different ways of managing your inventory. Once you classify it, then you manage that inventory. Once you classify it, you have to determine your policy. One way to determine your policy is managing your EPP, if you have it. If you don't have it, then you can identify this order frequency from your inventory classification. Once you have that, you can determine an observed EPP, and that observed EPP based on that order frequency can be used to generate the rest of your inventory. And since we're doing this automatically, you don't have to do it in classes. You can do this for each individual item because you have big data, you have your computers. You can do this for each individual item, called an item analysis. Now, if this is not optimal, but it's observed, if you don't know what your ordering cost and carrying cost are, but it's observed based on the order frequency of your A items, that's called an economically balanced inventory. So all this is in a paper that I wrote. But anyway, this is something that is extremely practical. It's very useful, and we see some applications of it in my courses, in my course, in the homework. That's all I have for ABC inventory classification. So between now and the next time I see you, I want to urge everyone to be safe and take care.